All right, so we're going to continue talking about probability here, and in this video I'm going to start with the easy stuff first and then get into the harder stuff. Okay, so we're going to start by talking about, didn't mean to do that, by talking about calculating odds, all right? So there are different ways of representing odds, but what are odds? The odds are just a comparison of the chance that something will occur compared to the chance of it not occurring. Okay, now, and some logic textbooks talk about both odds in favor and odds against. Typically, when it comes to sports betting and things like that, all that is represented are odds against, but um, at least three of the logic textbooks that I've used talk about both. So in this video, I'm going to be talking about both. Okay, so if we're talking about the odds in favor of a result or odds in favor of an event occurring, this is just a ratio between the number of favorable cases to the number of unfavorable cases. Okay, and then likewise, the odds against, this would be a ratio between the number of unfavorable cases and the number of favorable cases. Okay, so when you add up the number of favorable cases and the number of unfavorable cases, that gives you the number of total cases. Okay, so if I have 10 total coin flips, 7 are heads and 3 are tails, well, that means that the odds in favor of heads over tails is 7-3, right? Okay, and to calculate that as a percentage, obviously you would take the number of favorable cases, which is 7, and divide it by 10, which would give you a 70% chance of getting a heads over a tails. I mean, that's pretty simple, all right? Okay, now to calculate a percentage, then you would just take the number of favorable cases, multiply that by 100, and then divide it by the total number of cases, or you can divide and then multiply, okay? And then for calculating a percentage of unfavorable cases, you could either just subtract the percentage from 100, right? I mean, it goes both ways here, so this is relatively simple, okay? So, for example, suppose I have a 45% chance or a 0.45 chance of selecting a red marble and a 0.55 chance of selecting a blue marble, okay? And suppose all the marbles are either red or blue, so they're mutually exclusive and mutually exhaustive possibilities here, okay? Well, the odds in favor of selecting a blue marble, based on the fact that I have a 0.55 chance of selecting a blue marble, would just be this. All right, so I'm just going to take that 55 and put it over 100, and then reduce that to 11 over 20. Okay, so the 11 represents the favorable cases, the 20 represents the total cases. Okay, so the odds in favor of selecting a blue marble over a red marble are 11-9. Okay, so if you start with a percentage or a chance, you can calculate that as an odds, and then you can take odds and then represent them as a percentage. Again, this is relatively simple. Okay, now, what about formal probability then? Okay, so I used some of this notation in the previous video, and it wasn't too complicated, but maybe I should have started with this, all right? Okay, so this just stands for the probability of A. All right, A can be a result, an event. We can also talk about the probability of a given proposition, being true or false, but here we're talking about events. All right. Now, if A is necessary, meaning A can't possibly fail to occur, then the probability of A occurring, probability of getting result A is 1. Okay. Now, likewise, if A is impossible, meaning A can't possibly occur, then the probability of A is 0. All right. Okay, now if A is contingent, meaning that whether it occurs or not is a contingent matter, meaning A could possibly occur, A could possibly not occur. All right, so for any contingent event or contingent result, and again, for any contingent proposition, then the probability of A is going to be greater than 0 and less than 1. Okay, so most events that occur on a daily basis are going to be contingent events, meaning they actually occur but could have not occurred, and things that don't occur likewise are contingent. So if something doesn't occur but could possibly have occurred, it's contingent, and if something occurs but could have not occurred, likewise, it is contingent. Okay, now, and this seems pretty obvious as well, but it is not possible for the probability of a result or event to be less than 0 or greater than 1. So 0 means that it's impossible. 1 means that it's necessary. So, I mean, there can't be a 200% chance of an event occurring. Okay, now, obviously, percentage is higher than 1, probabilities higher than 1 and lower than 0 are possible when we're talking about profit and deficit. So if I talk about profits increasing by 400%, I'm not talking about events here per se. Likewise, if I say, profits, we had a net deficit, right? A negative deficit. That's not what we're talking about here. We're talking about the chance of events or results occurring. So the chance of an event occurring cannot be greater than 1, and it also cannot be lower than 0. So 0 means impossible, and you can't have anything lower than possible, and 1 means necessary, and you can't have anything greater than necessary. Okay, and then the other notation here is for conditional probability. So, P with parenthesis A and then a thresher stroke and then B. This just means the probability of A given B. Okay, so the probability of A occurring given that B has already occurred, or what we're talking about here is how the probability of A is conditioned upon B. Right? So that means that there's potentially some sort of dependence relation of some kind between A and B, right? Okay, now, so that all has to do with talking about the chance of simple events occurring, but what do we do when we want to calculate the chance of more than one event occurring, okay? All right, now, so conjunction methods are used for calculating the probability of at least 2 events occurring together. Okay, so these would be what we would call complex probabilities. Okay, now, and when it comes to this, the probability of a complex event occurring can't be greater than the probability of one of the atomic events occurring. Okay, so what I mean by that is the probability of A and B occurring together cannot be greater than the initial probability of A, and it also can't be greater than the initial probability of B. Like that's not possible. So the probability that I will eat dinner tonight and I will go to bed tonight can't be greater than the probability of me eating dinner on its own or the probability of me going to bed on its own. Why? Because it's more complex. Or the chance that Sally is a feminist and an investment banker can't be greater than the chance that she's just an investment banker or just a feminist. Okay, that's not possible. Now, but there are 2 different conjunction methods. One is called the restricted or special conjunction method, and then the other is called the general conjunction method. Okay, so what do we use the restricted method for? So the restricted method is used when we are calculating the probability of 2 independent events occurring together. Okay, so if A and B are independent, then that means the probability of A and B occurring together is equal to the probability of A multiplied by the probability of B. Okay, so my eating dinner tonight is an independent event of my going to bed tonight. I could eat dinner and not go to bed, or I could go to bed without dinner. Those are independent of each other. There's no reason to think they're dependent upon each other. Okay, so if there's a 50% chance that I'm going to eat dinner tonight and a 80% chance that I'm going to go to bed tonight, we would just multiply 0.5 times 0.8. and that would be the probability of those two things occurring together. Okay, so if two events are independent, you just take the initial chance of those events occurring and then multiply them together. Okay, now the general method is used when we do not consider the events to be independent. Okay, now it could be that we use the general method because they are actually dependent, but we would use the general method if we are kind of largely agnostic about whether or not those events are independent. So just because we treat them as if they are dependent doesn't mean they actually are dependent. There's a difference between not treating them as independent and them actually being dependent. Okay, so we use the general method only when we don't consider them to be independent, but it doesn't follow from that that they actually are dependent. I mean, for all we know, they could be actually dependent upon each other, they could be independent of each other, but it's just a matter of whether or not we're going to treat them as such. Okay, now, and it's here with the general method that we include conditional probability. So the probability of A and B, where A and B are not treated as if they are independent events, is the probability of A multiplied by the probability of B given A. So the probability of A and B occurring together is the probability of A multiplied by the probability of B given A. Okay, now if that probability, that conditional probability of B given A, or how B is conditioned upon A, is not known, that can actually be calculated. Okay, now if you know the probability of A and B already, okay, the probability of B given A will equal the probability of A and B divided by the probability of A on its own. So the conditional probability of B given A, probability of B given A, is equal to the probability of A and B divided by the probability of A. Okay, so here is an example of calculating a conditional probability. All right, so suppose I want to calculate the probability of selecting an even numbered card in a standard deck, given that the card is red. Okay, so that would be this. So the probability of selecting an even numbered card, given that the card is red. So I want to calculate the probability of E given R. All right. Okay, so there are 10 cards that are even numbered and red out of 52, right? So 2, 4, 6, 8, 10 of diamonds, 2, 4, 6, 8, 10 of hearts. That gives me 10 cards. So there are 10 cards that are even numbered and red out of 52. So the probability of getting a card that is both even and red is around 0.19, rounded to the nearest percentage, okay? Okay, and the probability of me getting a red card is 0.5. Half the cards in the deck are red and half the cards in the deck are black. Okay, so what I would do then is calculate the conditional probability of getting an even numbered card, given that it is red. That would be equal to 0.19 divided by 0.5, which is 0.38. So the probability of me getting an even numbered card, given that that card is red, is equal to 0.38. So I have a 38% chance of getting an even numbered card conditioned on that card being red. All right. Now, what about disjunction method? So disjunctions are either ors. So we use the disjunctive method for calculating the chance or the probability of either one event occurring or another event occurring. Okay, and what we need to remember when it comes to either or statements is that it's possible for either ors to be inclusive, meaning that it's possible for both to occur. All right, and when it comes to the restricted or special method for disjunction versus the general method of disjunction, this takes this into account. Okay, now, so the restricted method is used when the events are independent of each other and they are mutually exclusive. Okay, so if two events are independent and mutually exclusive, we would use the restricted or special method. I couldn't remember what our textbook says. It's restricted, restricted or special. Those terms are coextensive here. Okay, so if two events are independent or mutually exclusive, that means that the probability of A or B occurring equals the probability of A plus the probability of B. Okay, now keep in mind here that mutually exclusive events need not be mutually exhaustive. So just because you add the probability of A and B together this way, that doesn't mean you're going to get to 100. Now, if A and B are mutually exhaustive and mutually exclusive, meaning A and B exhaust all the possibilities and the occurrence of one means that the other one does not occur, then A plus B is going to equal 1. Right? It's going to be a 100% probability. Now, but if I'm talking about, for example, the probability of one team during March Madness winning or another team from March Madness winning, I mean, if we're in the round of 16, right, there are 14 other candidates other than Team A and Team B. Now, if we're down to finals where A and B are the only team left, those would be mutually exclusive and mutually exhaustive. But if we're in the Sweet 16, A and B are mutually exclusive. Both teams can't win, but they're not mutually exhaustive. So A could win, B could win, C could win. We've got 16 possibilities. We've got 16 candidate results here. Okay. Now, so here's an example. Suppose the probability of Michigan winning the game is 0.65. So Michigan is favored to win an individual game, 65%. All right, and suppose the probability of Michigan winning the Big Ten Conference is 0.45. Okay. Now, so what would we have? We would have that the probability of Michigan winning the game or winning the Big Ten outright is 0.65 plus 0.45, which would give us a value of 1.1. Okay, now, but remember, it's not possible for a given event or a given complex, compound event or whatever, to be greater than 1. I mean, the chance of Michigan winning the game or winning the Big Ten cannot be greater than 1. It can't be greater than a 100% chance. Okay, well, what's going on here? All right. Well, the problem here is that we have treated Michigan winning the game and Michigan winning the Big Ten as if they're independent and mutually exclusive, right? Now, but clearly winning an individual game and winning the entire conference, these are not mutually exclusive events. They could both occur. Okay, now, so that is why in these kinds of cases where the cases are not mutually exclusive, we need to use the general disjunction method. Okay, now, and that is this. The general disjunction method is the probability of A or B equals the probability of A plus the probability of B. And then from that, we subtract the probability of A multiplied by the probability of B. Okay, so notice what the general disjunctive method is. So the first half, the addition, that's the restricted disjunctive method. And then we are subtracting using the restricted conjunctive method. Now, you can also use the general conjunctive method, as I'll get to momentarily. Okay, so if two events are not mutually exclusive, so the probability of A or B, where A and B are not mutually exclusive, would be the probability of A plus the probability of B minus the probability of A multiplied by probability of B. Okay, so as we said, the probability of Michigan winning the game is 0.65. The probability of Michigan winning the Big Ten is 0.45. Okay, so we add those two values together, and then we subtract the fact that they are being multiplied. I forgot a period there, and that threw me off. So 0.65 times 0.45. So that gives us 1.1 minus 0.29, which means that the probability of Michigan either winning the game or winning the Big Ten outright is 0.81 or 81%. All right. Okay. Now, but what if those two events, in this case, Michigan winning the game and Michigan winning the Big Ten, what if they are dependent upon each other? Okay, well, what if Michigan losing the game means that they don't win the Big Ten? So, in order to win the Big Ten, they have to win this particular game. Okay, well, then instead of the restricted conjunction method that we would have in the second half of the equation, we would just use the general one, right? Which would be this: the probability of A plus B minus the probability of A multiplied by the conditional probability of B given A, okay? So if the events are dependent upon each other, you can just substitute the probability of B given A for the probability of B, right? Okay, and then the easiest one to remember is the negation method. The negation method is used for calculating the probability of some event not occurring. All right. So if the probability of A is a given value, to find the probability of not A, you would just subtract the probability of A from 1. Okay. So the probability of not A is equal to 1 minus the probability of A. Now, so anytime you are either given the probability of A or the probability of not A, you can always find the other one. So if you're given the probability of not A, right? So if the probability of not A is 0.2, the probability of A is 0.8. And likewise, if you're given the probability of A as being 0.8, you can subtract 0.8 from 1 and get that the probability of not A is 0.2. Okay? Now, and where all this becomes really useful is in using Bayes' theorem, which is a method that's used to calculate conditional probabilities. And it's a little more complex, all right? So since it's a little more complex, I'm going to keep this video a little shorter, and we will get into Bayes' theorem next.